Hello everyone. It is a great honor to be able to speak to you today. My name is Yuki Shimomura. I am a master student at the University of Tokyo. Today, I'd like to talk about through loud vocalization, which makes us feel as if we are vocalizing loudly. First, I want to explain why our research is important. In many situations, vocalization is a part of our daily life, and loud vocalization is also a part of our daily life. So, loud vocalization can be applied to VR in many situations. Loud vocalization has the potential to enrich the VR through content such as destroying buildings or experiencing a reverberation in mountains. Loud vocalization is also an action that is often associated with sense of exhilaration, so stress reduction using loud vocalization in VR can be expected. Loud vocalization seems to contribute to the VR in a variety of ways, but actual loud vocalization poses several problems. First, there are situations where we cannot speak due to physical factors such as a sore throat. We cannot also speak freely, even if we are at home, because of concerns for our neighbors. Therefore, is it possible to realize a smooth loud vocalization experience that does not require actual loud vocalization, but allows the user to feel the sensation of loud vocalization? Then we propose a method to present two stimuli instead of real loud vocalization. When we actually vocalize, we open our mouths in accordance with our vocal intentions, and our voices are produced from the vibration of our vocal cords. In addition, the vocalized voice is heard through bone conduction and air conduction. In contrast, we replaced vocal cords vibration with vibratory stimuli from vibrators and heard voice with auditory stimuli using headphones to realize the loud vocalization. This method allows the user to feel as if they are vocalizing loudly, even though they are not vocalizing loudly. In the next section, we will discuss the design of auditory and vibratory stimuli. To design the auditory stimuli, we define loud vocalization. The auditory stimuli is designed according to the definition of loud vocalization. The volume of normal conversation is around 50 to 65 decibel, and the 8-hour noise exposure limit, the volume at which listening for 8 hours a day would pose a safety hazard, is set at 85 decibel in many countries. Taking this into account, we set the loudness of loud vocalization at 80 decibel. This is not a strange value empirically, and it is a safe volume. As for the duration of vocalization, the shorter the duration, the weaker the sensation of vocalization, and the longer the duration, the more out of breath. Therefore, the duration was defined as 4 seconds, which was thought to be sufficient for the sensation of vocalization. Finally, the content of loud vocalization was defined as the vowel R. The vowel R was chosen because it is one of the simplest loud vocalization, and it is a sound that causes little discomfort when listening to the recording. The next step was to design the vibratory stimuli presented to the neck. The vibration perceived by the neck during vocalization is the vibration of the vocal cord, but the vibration of the vocal cords varies greatly from person to person and time to time, so it is difficult to design a uniform vibratory stimuli. Therefore, we decided to record vocalization generated from vocal cords vibration and use them as vibratory stimuli. In summary, the recorded voice of the user is used for the auditory and vibratory stimuli. The vibrators are placed symmetrically on the neck to mimic the actual position of the vocal cords. We conducted a user experiment to confirm whether the proposed method can provide the sense of loud vocalization. The experiment consists of a loud vocalization recording phase and presenting a sense of loud vocalization phase. 15 people participated in the experiment, and the evaluation was done with an ordinal scale using a questionnaire. In the experiment, 10 conditions were set. 5 conditions were set for vibration intensity, and 2 conditions were set for the vocalization, a low vocalization and a murmur, with different vibration conditions of the vocal cords. The participants were asked to answer a questionnaire for each condition, and different tasks were conducted several times to stabilize the evaluation. In addition, in order to align the presentation of the stimuli and the timing of the vocalization in the experiment, we controlled the timing of the vocalization of the participants using a graphic user interface. The interface shows the participants' timing of adjustment and inhalation and vocalization so that participants could vocalize at desired timing. These graphs show the experimental results. The top graph shows the median of the answers to the question whether the vibration presented to the neck was felt as their own. From the graph, we can see that the strong vibratory stimuli masks the difference between low vocalization and murmur. The lower graph shows the result of the responses to the question whether they felt a sense of loud vocalization or exhilaration through each experience. These graphs show that the sense of loud vocalization and exhilaration were greater under the low vocalization than under the murmur condition. The participants may have felt that it was unreasonable to hear clear vocalizations, even though they did not intend to vibrate their vocal cords. The following graph shows the main effects of vibration on sense of loud vocalization, exhilaration, and discomfort with presentation. The sense of loud vocalization and exhilaration can be caused with bigger vibration. An excessively strong vibration makes the presentation discomfort. Therefore, the intensity of the vibration should be appropriate. I would like to conclude by summarizing the above. We proposed a method to realize loud vocalization by vibratory stimuli to the larynx and auditory stimuli. Through experiments, we have shown that our method is capable of bringing about a sense of loud vocalization and exhilaration. Thus, our method has potential to make the VR more interactive and interesting, and contribute to digital mental health research. Thank you for your listening.